Let us solve this problem. Pause this video if you like to read the question. Let me tell you the answer. You may know that around a current-carrying wire, there is magnetic field. That is given by Ampere's law, which is shown by right-hand grip rule. It continues to happen in capacitor, where the current does not flow between the plates, but here it continues to charge, and therefore continues to increase the electric field, which is displacement current. The influence of the magnetic field around the charging plates continues to decrease with distance, just as the magnetic field around wire continues to decrease with distance. Inside the charging plate, the magnetic field depends on how many electric lines it has inside the loop, which means bigger is the oval, more is the magnetic field, till it reaches the edge of capacitor. If I were to draw a graph of displacement current, it will look like this. You do not have to know exactly, but the displacement current increases till is reached the edge of plate. Then it decreases as 1 over R. Answer 1 fits the answer. 2 is not true, as there are good amount of magnetic field are in the plates. 3 is definitely not true. 4 is definitely not true, as magnetic field is not constant between plates. As the plot shows, it increases with R, where R is the distance from center of plate. Once it reaches the edge of plate, it decreases, but never zero. Let us go to next problem. We draw this figure of dipole in electric field. The minimum energy is when negative to positive of the dipole in along the electric field, and has maximum energy is when it is in opposite direction. The figure now shows max potential energy. In terms of energy diagrams, it is this. If the dipole in is moved by 60 degrees, it takes some energy. Let us calculate it by using the mathematics. The dipole moment is Q times length of dipole, which is d vector. We are given and do not need to calculate it. In the question, the units are given wrong as centimeters instead of coulomb meters. Anyway, we correct it. The potential energy is minus P times E times cos angle of the dipole moment with respect to electric field. The energy required when the dipole is rotated 60 degrees from the minimum energy is this. Cos 60 degrees is half, and the energy required is this. The value of P and E is given in question, and the final value is 1 joule. We should never forget to do dimension analysis. The dipole unit is coulomb meter, and the electric field is Newton per coulomb. The final unit is Newton meters, which is same as joules. Do you remember work as force times distance? So the unit Newton times meters is same as joules. So the correct answer is 4. Let us go to another problem. This is a circuit problem. One should focus on the centerpiece of circuit which look complex, and we should simplify it. Let us draw separately. Finding equivalent resistance is not easy, unless the ratio of the resistances are same. This looks very similar to Wheatstone bridge. When ratio of the resistance is same, then the current at the diagonal resistance is 0. The ratio of the resistance is indeed the same, so the current in the diagonal resistance is 0. We can therefore safely remove it. This will then make it simple problem. Let us do it in next page. The circuit then becomes this, where we have removed diagonal resistance. Now the resistance 5 ohms and 3 ohms are in series, and we can add them as 8 ohms. 2.5 ohms and 1.5 ohms are in series, and we can add them to 4 ohms. Wait a minute. Now, 8 ohms and 4 ohms are in parallel, which is 8/3. Wait a minute again. Now all the resistance are in series. We can add 8 by 3 ohms and 1 by 3 ohms, and 1.5 ohms and 5.5 ohms. Total is 10 ohms, and we get a simple equivalent circuit. Now we can calculate the current, which is 10 by 5, which is 2 ampere. Hence the answer is 3. We go over to next problem, which is also a circuit. Normally, current is shown flowing from positive side of battery. But it looks like in this problem there is another source due to which the net current is 2 amperes, and change of current is 1 ampere positive per unit time. So just ignore the 5V as the source of current. It is meant to create a confusion. So there is opposing EMF against that current of 1V. We draw 1V like this. 5V is as is and does not depend on anything. Resistance has I times R drop. The drop is with respect to the 2 ampere current and not with respect to 5V. Hence, we add the voltage, not subtract it. Total voltage drop between A and B is 1 volt plus 5 volt plus 4 volt equals 10 volts. So the answer is 2. I have to admit it is a very confusing problem. Let us go to next problem. To solve if a diode is forward biased or reverse biased, it not only depends on circuit, but it depends on the potential at that time. This problem gives the equation of voltage, and we have to calculate the polarity at time t equals 15 nanoseconds. The term inside sine is equivalent to 270 degrees. We expand to 180 plus 90 and apply the formula of sine 180 degree plus theta equals minus sine theta. We also apply the formula that sine 90 degree equals 1. Therefore, we find the voltage is negative. Now, in the question, it is not given explicitly if the secondary voltage will generate the same negative voltage at the top. Normally, it is given by 2 dots. We show by 2 red dots here. We will assume that at the top wire, we have the same negative induced voltage. Now, regarding the diode symbol, I usually easily remember the diode symbol as arrowhead, allowing the current in same direction. You can see that negative voltage will generate negative current, and D1 will block the current, which means diode D1 is reverse biased. At the bottom wire it is positive, and we assume secondary coil of the transformer will generate same phase, so positive, which D2 will allow, so forward biased. Hence, the answer is 4. I will admit it is quite confusing question. This is our last problem. To solve, let us identify the gates and their operation. This one is NAND gate, and the operation is a multiplication with B, with the bar on the top of all. The bar reverses the signal. The small circle in front of AND gate makes it NAND gate. This gate is NOR gate, and it operates as a logical plus B and bar on the top of it. And the last one is AND gate. C and D are the inputs. This is the truth table that we have to calculate. Let us calculate the first row of truth table by making A as 0 and B as 0. We get the output of NAND as 0, and 0 makes 0, and reverse makes is 1. Next one is NOR gate. 0 plus 0 is 0, and reverse of that is 1. This is input to AND gate, which is 1 and 1, which produces 1. Let us calculate the truth table of the next row, which is A equals 0 and B equals 1. Can you fill in the squares? Pause the video if you have to. Let me answer. We get output as 0. Let us do the third row on truth table, which is when A equals 1 and B equals 0. Can you verify all the boxed items? The output is 0. Please be sure you can calculate the box items accurately. Now we go to fourth and the last row. Here the A is 1 and B is 1. Please make sure you can calculate the boxed items. The output is 0. Let us look at the filled-up truth table. It looks like truth table of NOR. Hence the answer is 2. Before we end this video, we like to say that if you like my teaching, please like, share, and subscribe to this video. Goodbye.